Hello and welcome back everyone. In this video, we're going to talk about Introduction to Robotics, but Chapter 2. Now, we already understood the couple of instances and couple of basics of robotics, and in this video, we want to continue and learn more about it. Of course, this is an extension for the Chapter 1, but we're going along and following more directions of how you can explore robotics and what all direction you can see in robotics. So without any further ado, let's get started. Okay, so now we have chapter 2 now, which is of module 1, and we are on pretty good track. And I hope you are enjoying it so far, of course. Let's look at origins of robotics, of course. And these are all very basics and fundamental. And we are going to look at how all these robots that we see are basically built around. So the concept of artificial life, essentially using machines as a life form, originated centuries back by the automata, which is a ancient Greek and in China. So both Greece and China are contributors for this, and it started with automata or automation, as we call it now, called these days. These mechanical devices were capable of performing simple tasks such as moving a ball or ringing a bell. Now, the main idea at that time was to automate something. That's why it's known as automata. And automating something or doing some simple tasks with the help of machines included you moving a ball or ringing a bell, which is very simple and very straightforward. In the later part, what happened is like clockmakers developed complex mechanical clocks that could perform various functions such as striking a bell or displaying phases of the moon. Now, if you are not from the watch world, let me tell you a little bit of things which are there. If you buy a watch in the market, there are two kinds of watches. One is a quartz watch, which is basically battery powered. Second is a mechanical or automatic watch, which is essentially like watches which don't require a battery. They have self-winding wheels, which wind the watch and help them move. And they have all these complexions which are there, or complications which are there, as we say, which help you do a lot of things. And that's where it actually started with robotics. So originally speaking, even showing the phase of the moon was quite a big thing at that time. And watchmakers could see that, timing the things or, having a clock that would actually can help us, do all these complex mathematical performances. And that's where it all started. Now, let's see the development phases as well. Okay, the modern era of robotics began in 20th century with the development of electronics and computer technology. Now, as you know, these days, without electronics and computer, it's quite hard to imagine any sort of robot or form existing out there in the market. So it started back in the 20th century. In 1950, the first industrial robot, the Ultimate, was developed by George DeVol and Joseph Edinburgh. Now, this is still very early, I would say, in 1950. But then we were able to see the shape and form that could be visible for robots, and that's where it actually started. Let's see, what was it about though? The robot was designed to perform repetitive tasks in a manufacturing and assembly application. Now, you can clearly see now what we did is like we developed from something which was repetitive and we removed the repetition and we added a machine to do that. That machine allowed us to, have the ability to, build better solutions and build better systems as well. And that's where it all started. Okay. In the 1960s and 1970s, the field of robotics began to expand, including mobile robots and other type of robots for non-industrial application. Now, you see what we're doing. We are essentially building industrial and non-industrial robots both at the same time. Now, what that led to? That led to an era where, commercial robots were also accessible to normal public for their home use case as well. We can clearly see these things happening, and we can clearly see that these things bringing into life these days when we talk about vacuum cleaning robot, or when we talk about roti maker robots as well these days, or idli maker robot. All these robots are essentially like domestic robots which are kept and used in day-to-day life. Okay, and then we have some milestones. Now, these milestones are essentially significant when you want to understand the journey of robots. Now, a lot of you might be thinking why I'm talking a lot about journey and the history of robots. The main reason is so that you know what is the core essential element of a robot, and it's going to help you build that significant amount of trust which is there. So there are a lot of significant milestones in robotic history. Some of them we are going to look at as follows. Okay. In 1954, development of the first industrial robot, the Ultimate, by George DeVol and Joseph Edinburgh. Now, we also talked about 1950, But actually speaking, 1954 was the time when it actually got launched. Okay, so you have to remember both the dates, very important. 1961, introduction of the first mobile robot, Shaky by SRA International. Shaky was capable of moving around using camera to analyze the environment. Now, you can already see in 1961, we were able to do image processing, and we were already able to do, image-based analysis. And that's quite advanced as looking at, where we were at 1961. Now, in those scenarios as well, the first thing that you can see what people were doing was trying to solve industrial solutions, okay? Because ultimately speaking, robots have one thing which is pretty strong, is the physical capability of things, okay? In industrial automation and in an industrial environment, things can get very heavy and humans can, break at a lot of time. That's why people start to solve these milestones and start to build upon these milestones quite early, just to make sure that, we have robots in the industry first. Then in 1972, development of the first successful humanoid robot, Warbot 1, by the Waseda University in Japan. Warbot 1 was capable of walking and performing simple tasks. Now, 1972 was the time when robots already started walking. Although we can see that, till date, humanoid robots are still very early and they're still, trying to, make them walk and, do all the actions very naturally. Thanks to Boston Dynamics, things has been done quite fast now. But, Japan is still one of the leaders in robots. 1984, we have the first autonomous robot, which was the Mars rover by NASA. Mars rover was designed to explore the surface of the moon without human intervention. Now, this is the era where we start doing autonomous robots, where we start to remove the control of humans, okay? And this was the time when we were like, okay, maybe having a robot is good, but having an autonomous robot is even more better. One of the reasons why this is important, or this is a key milestone, is the fact that when we look at robots, okay, robots in general are not really designed to, work with humans all the time, okay? There is a different category of robots which are designed to work with humans, and those are known as cobots, okay? So generally speaking, when you talk about robots, or when you talk about just robotics in general, they are essentially designed to, help or reduce the human cost and reduce the human risk, and or make it easier for the user or the consumer to replace it with a machine. The reason is because machines are, even if something happens with a machine, it's not really a problem. Second, humans' lives are obviously much more costlier. And the third, that machines don't get tired, okay, and they don't make a lot of mistakes. Obviously they make mistakes, but they don't really make a lot of mistakes. Keeping all these things in mind, companies like or institutions like NASA, thought that, why not we make something which is going to help us perform missions as well on the moon. NASA, apart from NASA, I would say USA in general is always quite ahead in robotics, and they're already I think there are already 10 steps ahead in robotics as compared to any other world. Of course, Japan also is at least 15 or 10 steps ahead of any other thing which is happening in the world. But the thing is, like, in the US especially, democratizing things or democratizing robots became a very popular thing. People started buying robots, people started, implementing robots, and at a very early stage, because everything happens so fast in the US that the culture adapted very well. A lot of talking in US website. Next up, we have 1997, where the first commercial robot was successfully deployed. Now we see that as Roomba vacuum cleaner by the iRobot. Now, till date, Roomba vacuum cleaner is one of the most popular robots that everyone has. I actually have a Roomba robot as well. Not here in Germany, but back in Sweden where my house is. Over there, I have a Roomba robot, and trust me, Roomba robot is one of the most friendliest robot that you would see, just because it's designed so well and it works so well, and it cleans your house so well. Okay, and so it's still on the very fundamental task of cleaning your house, but cleaning your house. But cleaning your house can be still very challenging for a lot of machines. So, having a robot which is dedicated to, clean your house, I think it's a pretty good shot. And all of these robots that you see and all of these, machines that you see have the simple capability that, they can be deployed anywhere you want, okay, anywhere. And that's where Roomba comes into picture, and that's where all the other robots also come into picture, okay, very important for you. And it started in 1997, but till date, since you see Roomba, they have developed so much. Okay, now you can select which room you don't want to clean, which room you want to clean. You can also set timers. Okay, so what time of the day you're not at home, so the Roomba automatically cleans your house and everything, and it makes it quite a popular robot of choice. Okay, you don't really need to have a vacuum cleaner. It's like a robot which is gonna clean your house all day, all the time, and that's kind of cool actually. 2015, introduction of the first humanoid robot capable of running Atlas, the Boston Dynamics. The same thing that I was talking about, Boston Dynamics robot is one of the most advanced one. You should definitely check this out on YouTube as well. And Boston Dynamics did a very interesting thing that they made a full-size humanoid robot which looks like human and was doing backflips. Okay, I mean, imagine in the world of robots where things were not really that fastly accelerated. They made a humanoid robot that could do backflips, and it was quite a complex task, of course. But yeah, they did. They made that happen, and Atlas is still today one of the most powerful humanoids that we all know. And Atlas was designed for search and rescue application. Essentially, if you see till date, 2023, Atlas is one of those robots which is capable of lifting boxes, dropping boxes, moving things around, and a lot more things. And all of these things kept in mind that Atlas still remains a robot which is controlled by a human. It's not a fully autonomous robot. It's a semi-autonomous robot, which means half of it is controlled by its own controller, and half of it is controlled by a human. Which means that human gives instruction, Atlas listen to it, and performs action. Very straightforward, very cool as well. Then we move on to modern advancements in robotics. In recent years, robots has advanced rapidly with a significant amount in areas such as AI, machine learning, and computer vision. Now, some of the modern advancements in robotics is something that we're going to look at. But till date, if you see AI, machine learning, and computer vision, all of these things are very important for a robot. One of the reason is because a robot is running on a lot of sensors, and a lot of sensors means a lot of data. Now, in order to significantly understand and significantly, analyze and work on the data, you need something which is robust enough to and prepared enough for this. And that's where artificial intelligence and machine learning comes into picture. Computer vision was already there because, we were using cameras all the time, and using cameras allowed us, have a better system, of course, and, this actually made and accelerated the journey quite fast. Let's look at some of the advancements which are there. AI and machine learning, these technology allow robots to learn from their environment and adapt to the situation. Now, if you see, a lot of robots actually are capable of automatically avoiding obstacles just because they know how to avoid obstacles and get through them. And now, this technology was initially not there, but as we move forward, as we move forward and as we developed in the field of AI, what happened is like more and more machines were capable of designing and moving with their own will. Okay, and they knew how to handle situations very well because they were trained, and they learned how to move around, how to go on left or right, and they were capable of understanding, okay, this is where I have to go, this is where I have to go, and they can take those action as well. So modern advancements in AI helped to boost this time and to boost this situation quite fast. Very important. Then you have computer vision. Now, a lot of people don't really know what computer vision is. It's more or less like a Snapchat filter or Instagram filter, which is there, okay? You're tracking an object, you're detecting an object, and then you're applying some sort of computation to make something happen, okay? So computer vision allows robots to interpret visual data and recognize objects in the environment, okay? You must have seen a lot of robot movies where the robots detect human and they figure out, what the human is trying to say. All of these things happen because they have a computer vision system or a camera which help them see what things that are happening around them, and then interpret it. And then you say, okay, there's a human, I should say hi. There's a cat, I should probably pat on the cat, and things like those. So all of these things allow a robot or allow like any sort of a robotic system to have that sense and have that capability of doing things pretty well. Then you have soft robots, very advanced stage. Okay, very advanced stage. Still under research. Okay, soft robots involve use of flexible material actuators to create robots that can interact more safely with humans and other objects. Now, a lot of areas of soft robots are still in the development. One of the areas is, in surgery, that soft robot can go inside your body and particularly place a medicine at the right spot so that you can get healed faster. Now, all of these soft robots are very advanced in stage, and they have not really developed to be commercially available. So you don't see a lot of soft robots, but hopefully by let's say 2023, 2030 or 2040, we should be able to see something much more advanced in this field as well. Okay. And then you have swarm robots, and a lot of you might have not really heard about swarm. Okay, so swarm robotics means that you have multiple robots which are going to focus and multiply, like like a beehive or something, and they're going to work together. Okay, the main idea is that they're going to coordinate and they're going to work together on one single task. The main benefit of this thing is that you are avoiding the part where one single robot has to do everything, and a lot of tasks can be divided. So a lot of small robots can do all these small tasks, and it becomes quite efficient and quite fast, and that's the beauty of swarm robots. Then you have autonomous vehicles, okay, which are type of robots that can operate without humans. Okay, they are expected to revolutionize the transportation industry. Now, a lot of you already know self-driving cars, but back in the US, I think 2 years back or 3 years back, I think there's a company known as Cruise, Cruise, Cruise Robotics. Okay, though that company is basically making self-driving cars, and right now, 2023, they are actually like running self-driving cars as well. So there's an app for them. It's known as Cruise. You can download the app only if you're in San Francisco, and you can book a car and it will come to you automatically, and there is no driver. I mean, it sounds quite scary, but it's actually very cool that you sit in the car and the car is going to drag you around, and it's all autonomous. You don't really have to do anything with it. So very, very cool concept and very cool idea, of course. So yeah, those things are there. And let's talk about current status of robotics. Okay, where are we right now? Robots is now a mature field with a wide range of application technology. Robots is used in various industries such as manufacturing, healthcare, space exploration. And current state of robotics is characterized by a couple of things. Okay, so we're already at a very advanced stage because we started very early. Okay, and but there is still a lot of room for improvement. Softwares are not that strong yet. I would say, being in the field of software engineering, robotic softwares are still learning and still building, and probably take another couple of decades to be mature. We have AI, artificial intelligence, and machine learning capabilities, and increased use of sensor and data analytics. So these two things are quite important for you. Okay, if when you talk about sensor and data analytics, what happens is, like, since we are having a lot of sensors from the robot, and they can see and they can feel a lot of things, we don't really have good enough softwares to analyze and conclude from this data. Like, if the robot sees that human is crying, what does it interpret? I mean, we have the data, but we don't have the software to recognize that the human is feeling sad. Okay, so all of these things are still under development, and probably maybe another decade or so, I think 10 years or 20 years, I think then it will start to get mature. And once it starts to get mature, then you can see that, things are actually building up. Development of more human-like robots. Okay, humanoid robots are still under development, but I think that's going to change very fast. I think I can feel that things are changing, increasing very fast. Integration of robotics into various industries and application. Now, integration of robotics has not been done properly yet. We still are scared of robots, and we are trying to make cobots which are capable of working with the humans, and that's industry integration is still a little long way through, but it's still going on. So to conclude, we have the history of robotics has been marked by significant advancements, milestones, and the future of robotics is exciting. Future of robotics is exciting with the potential of robots to become more intelligent, adaptable, and get in everyday life. Now, clearly, you can see that things are shaping up. And if you are someone who is planning to go into the field of robotics, I think it's probably very good time right now. Another thing which is quite important to understand is that resources regarding robotics are becoming very, very easy. Okay, you can find a lot of resources, like even this course as well. It's going to give you a lot of edge when you talk about robotics. So when you say that things are becoming or things are improving, it means that there are a lot of people who are also contributing into the field of robotics as well. And yeah, I hope this course helps you build something incredible, and you also contribute into the field of robotics for the world as well. Cool. But that would be all for me for today. But I hope you had a lot of fun understanding, building, and visualizing how robots started. And in the next class, we'll talk a lot more about robots. Till then, happy learning and peace.